And we're going to graph some logarithms, which if you can graph an exponential function, you can graph a logarithmic function. Now, the only thing that's really important is when you're graphing a log, you have to realize that there is a vertical asymptote. When we graph exponentials, there is a horizontal asymptote, and we're going to see, since we're flipping x and y, there's going to be a vertical asymptote. You need to pay attention to that when you draw it, just like you need to pay attention to the horizontal asymptote when you draw exponentials. The rest of this will come up when we see the graph. So let's first start off by graphing an exponential function. This is just 2 to the x, so this is our parent function, and we've been using -1 to +3. Remember, 2 to the 0 power is 1, 2 to the first is 2, and then we're following a pattern here. 2 squared is 4, 2 cubed is 8, and 2 to the negative first is 1/2. Again, 2 to the negative first, that's the wrong side of the fraction bar, so it's 1 over 2 to the first, which is 1/2. So, because there is no vertical shift, there is an asymptote, oops, that's not horizontal, along the x-axis, so I'm going to draw that. And we draw that as a dashed line because it's not actually part of the function. And now when I plot those points, -1 is at 1/2, 0 is at 1, 1 is at 2, 2 is at 4, and 3 is at 8. So it looks something like this, and that's pretty good. There is a horizontal asymptote that is going to level off, and it's going to get closer and closer and closer to 0, but it will never quite get there. So all the exponential functions have the same domain, -infinity to +infinity. The range, since the horizontal asymptote didn't move, the smallest x value is 0, and it goes up forever, so 0 to infinity, and it never hits 0, so we use parentheses. And since, again, it didn't move, it's y equals 0. Okay, that's your horizontal asymptote. Now, we need this to be able to graph a logarithm. So what we're going to do is, I'm going to now graph a base 2 logarithm. That's red, a base 2 logarithm. Before I do that, I'm going to list that same parent function. Okay, if you want me to do base 2 logarithm, I'm going to start with a base 2 exponent. 1, 2, 4, 8. Okay, logarithms and exponential functions are inverses of each other. So inverse means you flip x and y. Everywhere you see an x, you're going to put a y. So what I'm going to do now is flip this table. So all my x's are going to become my y's. So now it's -1, 0, 1, 2, 3 on the right. And these will now be my x's. 1/2, 1, 2, 4, 8. This is called a base 2 logarithm. So let's graph it. 1/2 is at -1. 1 is at 0. That's 1/2 is at -1. Right? I don't know why I keep going right here. There. 1 is at 0. 2 is at 1, 4 is at 2, and 8 is at 3. Now, this follows the horizontal shift. So since it didn't move left and right, the asymptote is x equals 0. Because instead of y equals 0, we're using x now. So this is a vertical asymptote. And it's not going to hit the vertical asymptote either. So when you draw it, it looks like this. And then it goes down along this asymptote forever. So the domain now, unlike in exponentials where the domain was forever left and forever right, now that's the range, forever down and forever up, -infinity to infinity. We flipped x and y, right? So what used to be the domain is now the range. Now, we got to flip this as well. Instead of 0 to infinity going up, it's 0 to infinity going left and right. The domain is 0 to infinity. Okay, and again, it doesn't hit 0. So you see how these just got flipped? That's what's happening here, because these x and y got flipped. The input is now the output and vice versa. So this is called a logarithm. And we'll talk more about how to evaluate logarithms later. Right now, we're just focusing on graphing them. If it says to graph a logarithm, the first thing you want to do is look at the base of the logarithm. This is base 3, so I'm going to make a parent function for base 3 exponential. -1, 0, 1, 2, 3. We've done this before. 1, 3, 9, 27. But now I have a base 3 exponent. I want to make it a base 3 log, so I'm going to flip it, and this will be base 3 log. This will be my parent function for a base 3 logarithm. Flip it. 1/3, -1. 1, 0, 3, 1, 9, 2. I can't fit that on the grid anyway, so I'm just going to stop. Okay, 27, 3. Now, that's a base 3 log, but this is a base 3 log that has been translated. And we have to remember that all functions behave the same way. On the inside, if you have an x plus 1, that's going to move it left 1. And on the outside, plus 3 is going to move it up 3. You just have to remember that this is what we're going to be translating. We're going to go left 1, so that changes the x's. 1/3 minus 1 is negative 2/3. 1 minus 1 is 0. 3 minus 1 is 2, and 9 minus 1 is 8. Up 3 from negative 1 is now 2, 0 plus 3, 1 plus 3, and 2 plus 3. So those points actually fit on my graph. The other thing I want to remember is since this thing went left 1, the vertical asymptote is at negative 1, right here. So when I draw it, I shouldn't have anything to the left of that. If I do, I know I did something wrong. Let's plot it. Negative 2/3 is about right here at positive 2. 0 is at positive 3. 2 is at 4. 1, 2, 3, 4. And 8 is at 5. So this is the graph of a base 3 logarithm. And when I draw it, ooh, that's not very good. Let's try that. Do better. Like this. And then it goes down forever, following that asymptote. Okay. The domain, since it went left 1, it's negative 1 to infinity. Negative 1 is the smallest x value, and it goes forever to the right, so to infinity. Range goes all the way down and all the way up, and all logarithms will have the same range, negative infinity to positive infinity. Just like all exponentials have the same domain, all logarithms have that domain because x and y gets flipped. Let's do one more. Base 2 logarithm means I'm going to start with a base 2 exponential. This will be my parent function, 1/2, 1, 2, 4, 8. It's the same parent function we've been using for the past several days. To get a base 2 logarithm parent function, you flip it. Now it's 1/2, 1, 2, 4, 8, and negative 1, 0, 1, 2, 3. So I'm just flipping the table. Now I can translate right 3, down 4. Okay, so this is the same as when we did radicals, but now we're doing it with logarithms, and the same as when we did exponentials and quadratics. We've done this a bunch. Right 3, add 3. 3.5, 4, 5, 7, 11. I'm adding 3 to all the x's. Down 4, negative 5, negative 4, negative 3, negative 2, negative 1. This should be a nice pattern because we started with a nice pattern here. So after all the translations, it gets flipped. Those end up over here. So it should be a nice pattern. Because this thing went right 3, I know my asymptote should be x equals 3. So when I draw it, I shouldn't have anything to the left of 3. Okay. Now we'll go plot the points. 3.5 is at negative 5 right here. 4 is at negative 4. 5 is at negative 3. 7 is at negative 2. And I'll try and fit 11 on there is at negative 1 like that. So it looks like this. And again, it follows the asymptote. So if you draw the asymptote first, it keeps you out of trouble. Okay. Domain, 3 to infinity. The x's, most x is 3. It goes forever to the right. So 3 to infinity. Range, all of them have the same range. All real numbers, negative infinity to positive infinity. So you're going to start with a parent exponential function. Then you can flip it to get a parent log function. Then you can translate as you need to. But it's very similar to graphing everything else we've graphed. You just need to know how to get the parent functions. So do your practice problems, smash that like, and smash that subscribe.